What is up, guys? Welcome to this video. In this video, we'll be diving into the queue implementation using an array. But before I do that, I want to better explain how the dequeue functionality actually works. So basically, since we'll be removing the first element from the queue, right? So because it's a first in first out data structure, so we need to remove the first element. And if we remove the first element from the array, our array is left empty. So we should essentially move every element to the left, right? So that's what this means over here. Qn minus 1 is equal to Qn, because we'll move every element to the left by 1, right? And that basically means that we'll just change the back index as well by 1 to the left, right? So this will make more sense as we code it along, but let us actually dive into the code implementation, right? So I have my stack implementation here. Let me close all that up. Let me clear my terminals. And what I'll do is I'll collapse everything and I'll create a duplicate of this, right? I'll create let me rename this to our queue demo, right? Queue demo, okay. And inside our queue demo, we have all the folders that we want. And inside our source, what I'll do is I'll change this to, rather than stack array, I'll call this queue array, and that will have to change in the constructor as well. We'll be creating a queue array, and we'll be initializing a queue array over here. So what I'll do is I'll just remove it. Let me just comment. Actually, let me just remove everything. Okay, I'll just remove everything, and we'll be creating a stack using a queue now. And our print method will also change slightly. We'll dive into the details later, but we'll be creating a queue array over here. And we're no longer using top, but that's basically our queue array. And so I'll just save that, and then I have to also rename the file. So you can see that I think Visual Studio Code will give us an error if the file is not named as the same as the class name. We'll get an error, right? So that's basically QArray is our new class, and this should work perfectly fine. Now let us go to our make file and let us add our QArray, right? So we were dealing with stack array, now we'll be dealing with QArray. I'm just gonna add the QArray in there. And I'll just leave the Java stack as it is. We'll change that to Q later, and I'll save that. And now if I come into our QArray, everything should be working fine. So what I'll do is I'll cd out, and then I'll cd into our Q demo, and then I will do a make over there. So let's see if this works. Any compilation errors? Cool, no compilation errors. And then I will cd up, and then cd into Q demo. cd into Q demo, right? And then I'm just going to do Java. I actually need to cd into bin, and then I'll do Java Q array. So it says creating stack using queue. Okay, actually, sorry, that's wrong. It's actually creating a queue using an array, right? And then we'll be creating a queue array at the top there. Okay. So it looks like we have set up our environment. Now we can actually start jumping into the details of it. Okay. So the first thing is that we'll be initializing a queue array. So it's no longer a stack array. So I'll just call it a queue array like that. And we'll be initializing it to the length of n. And then so there's no longer a push method. The push method changes slightly. Now we have size, we have empty, we have p. We still have empty. We no longer have pop, that changes. And also our print statement changes slightly, right? So what I'll do is I will come back over here, and I will look at all the different functions that we have. And what I'll do is I will actually start implementing this. So the first thing we need to do is we need to initialize this to back. So we'll be using back now, and back is going to be set to -1. And let us start with the enqueue method. So the enqueue method, NQEE. All right, that's the right spelling. Spelling of Q always trips me up. Where is our, yeah, there we go. So NQ, right, is just going to take the object, and if it's less than the size of the array, then we're going to just add the element into our queue, right? So for this particular example, I would like you guys, I'll push this code to the repository, and I would like you guys to add this functionality where you're checking if it's not empty, and where you're checking if it's within that size of the array. So that'll be an exercise for you guys. Play around with the code, and you'll be able to add that. You'll have to use the isEmpty function, and to basically access that. And so for the NQ method, what we're doing is we're adding the element. So back changes to back plus 1. So I'll use a shortcut plus equal 1, right? And then our QueueArray, the topmost elements, the back element will be equal to the new value. So the new person has entered the queue, but they're going to be at the back of the queue now, right? So that if we want to get the size, we have to just do back plus 1, right? And then if it's empty, we just need to check if back is equal to -1. And if that's the case, it means it's empty, right? And now there's no longer peek, there's the front method, right? Front is basically going to tell us who is at the top of the queue. So the front element will be 0, right? And basically that is about it. So there's NQ, there's the size, there's empty, there's front, and then instead of pop, we're using the DQ functionality. And if the removing value will be the person at the top of the because it's a first in first out data structure, so the person at the top of the queue will be removed first, and then the DQ functionality is slightly different. So because we'll be removing an array, right? So let me explain this better. So initially what we'll have is we'll have some sort of list, right, with A, B, C, D, E, right? So this will be our initial queue. It's a first in first out data structure. Now if someone gets removed from the queue, right, if A is removed, it'll become like this, right? We have to remove A, and then there's B, C, D, E, right? So instead of having this happen, what we can do is we can move every element to the left, right, such that such that the array becomes like this, right? So it'll be like B, C, D, E, and then we'll have a new space so that someone new can be added into the array. All right, so now what we'll do is we'll continue with doing the DQ functionality. So we know that the removing value is going to be the first person, and we are also changing the back value, but this has to be done in an array now, right? So we'll do a quick array. We'll create the topmost element is going to now be 0. So actually it's going to be 1, right? So what we'll do is we're just iterating from the first element onwards now, okay? So I'm just going to do less than back, right? So because our back will point to E over here, right, which is that index. And what we'll do is we'll do I plus plus, all right? So let's see. So the backmost element is that, and we'll be going through till the end, right? So what we'll do is now in our QueueArray, we're going to assign, actually I think it includes the lastmost element as well. What we'll do is QueueArray is going to we're just going to do I minus 1, right? So we want to just move all the positions to the left by 1, right? So we'll just do QueueArray, we'll just assign the actual I element. So what this will do is it's going to assign A's position to B. So B, C, D, E, and then it's going to basically go all the way until back, the backmost element, which is E, and this should work, right? Our array should actually move to the left, okay? So our DQ functionality should work like this, and we can finally move, we just have to move our back by 1, right? So our back pointer will just move by 1 to the left, all right? So that is it. That is it with the DQ functionality. Of course, this is incomplete. You need to add the functionality for checking if it's, you know, if we're already on -1, we can no longer remove any elements. Otherwise, we'll get index out of bounds error, right? So that is the DQ functionality. And then it's been a while since we've actually tested, but let's see. So the top of the queue will basically be, so we'll start from 0 and we'll go all the way till the back. And then we'll have to just iterate by 1 and we'll just print I. All right. So this is the end of the queue. And that is it. So we've created our queue array. And now let us actually try pushing people into our, actually, let me rename this to queue. I'll just call it queue like that. And let us actually enqueue people in our queue, right? So let's say we're at Burger King. We are going to say that Kill is the first person in the queue. And we will actually just do a quick, let me also just add the separator there. Let me also just add that there. What I'll do is I'm just going to print. So let me add a few more people to the queue. So Akil, Asif, Tov, and I'm just going to do queue.print, okay, so that I can see who all are in the queue. All right, I'm going to save the file and let us test out if our enqueue functionality works. So I'm going to make, oh, looks like we got an array, got an error. So this is the error. So we're using stack array over here and we've clearly removed that. Let me make that again. Still get another error. Removing value, we're looking at stack array again over here, another error. Change that. Okay, let me run that again. Awesome, no more errors. Now I'm just going to run this. You can see that we're creating a queue using an array, and then we can see top of the queue and we can see end of the queue. So it's a first in, first out data structure. So whoever was enqueued first will be at the top, right? So that is the queue. Now the enqueue works, so that's great. Now let us actually try do the dequeue. All right. So now I'm just going to do queue.dequeue. Okay. And then I'll put the print, one print up here. And then I'll put another print. Put another print down there, right? So now I will make the file again. And then I will run this. And you can see that once the dequeue function runs, Akil is no longer in the queue because it's a first in, first out structure. The first element, Akil, was removed from the queue, right? So that's basically dequeue working, and that's awesome. Now we can move on and talk about the size. So we can also just check out the size. I'll just do system.out print size of queue. And it's just going to be queue.size, right? And let's also just add the other functionality here. Awesome. So we could also use the empty, but the empty is actually more relevant for using it in enqueue and dequeue because you don't want to add elements once you've reached the full size of the array, right? Because that basically will throw an error, right? So because you get an index out of bounds error. So I'm not going to go through the empty method. The front method is there, dequeue of tested, print of tested, and that is about it. So if I make that and I run this, you can see that the size of queue is 2 at the end of the day, right? So that brings us to the end of this video. I know it's a very brute force solution. You can make the solution more elegant. You can actually use, in the right places, you can also use the right functionality. So when enqueuing, you need to check, have you hit the max size, right? And to do that, I think it would be most recommended you create a variable here, max size. Okay, so that will be like an instance variable. And then when we're creating our queue array, we can set max size. Oh, sorry, I haven't defined a type for max size. And I'll do max size, and that'll equal to n, right? So now over here, when I'm enqueuing an element, I'll just check if max size, if back is equal to, So I think if back minus one, or yeah, back minus one. So if back minus one is equal to the max size, right? Alternatively, you can say if back is equal to max size. Then we don't want anything happening. Then we just want to get out, right? Then we'll say that, you know, system.out print line Q is full, right? You cannot add any more elements because once the Q is full, okay? Otherwise, you can do this stuff, right? So that's basically how, you know, you can add some more validation. You know, also in our DQ method, you don't want to remove any elements once the array is, once B is equal to -1. So you can add, like, you know, you can add a functionality there. You can say if, you know, if QueueArray is empty, right? And in our isEmpty method, we're actually doing this check if back is equal to -1. Then we can just do, then we cannot do this top of the queue stuff. Like we cannot remove, sorry, then we cannot remove any elements in the DQ method. All right. So I hope that was helpful, guys. I want you guys to play a little more with this. What I'll do is I'll just push this code real quick. Yeah, git commit -m q demo. Awesome. So all the code is available on GitHub now. I'll publish the links in the slides and you guys will be able to pull it and play around with it. Thank you so much for watching. I'll see you guys in the next one. Cheers.